evening to you all. I trust you are all doing well. So today we continue our journey in ecology. So now we've exposed ourselves to the basic ecological terms. Then last time we met, we talked about some habitats, some major habitats that we have, which we concluded on them all. We also highlighted on symbiosis, predation, and all those terms. So tonight we'll be looking at some interrelationship between organisms in such ecosystem. So we just talk about the major ecosystems. Then today we will be looking at how living organisms relate. So that is the outcome of the interdependency of living things in their environment. So I'll be engaging you, so please, yeah, so we look at this first, the interdependency, then we look at the outcome of the interdependency. So this is our topic for the day: interdependency of living organisms in the various ecological habitats. So now we've been exposed to the major ecological habitat, that was the coral reef, the desert, the Arctic tundra, the freshwater habitat, the grassland, and a whole lot of major ecological habitats. So if there are questions from the previous lesson, you can bring. But if something that we talk about is made known in the previous lesson, I will encourage you to visit the YouTube channel to find the knowledge for yourself. Alright. So I'm sure by now everything is set. We can continue the lesson. So I would like someone to just come on board, just explain to us how living organisms relate or depend on each other. You can cite an example, any example that you want to cite to prove that living organisms depend on each other for their survival. After that intro, we can look at how organisms interdepend on each other in the forest, how they coexist in the forest habitat. Then we can talk about in the other major ecological habitats, that is in the freshwater, the marine, and some other places. So we will talk about the grassland and the rest. But for now, any general example to show us how living organisms depend on each other for their survival. So please, anyone online, you can unmute yourself, then you help us to get any example just to prove to us or the essence, the importance of living organism interdepending on each other to achieve the ecosystem, that's the stability that we need to run the environment. Susanna, yeah, Akia, yeah.
Humans depend on plants for their survival.
So Zana just talk about animals relying on plant for food. So she just make a one-sided emphasis. So any other person, you can say more than one, that would be better. But she just talk about humans depending on plant. But now we don't know anything about plant depending on humans. Yeah, Lillian, your hand is up. Lillian.
That means animals depend on plants for survival, like shelter, oxygen, and food.
Okay. Are you done?
Yes, sir.
Okay, thank you very much. So she also made a one-sided emphasis, that's the humans dependent on plant for all those that she mentioned. So now we can. So is it that only animals depend on plant? Does plant also depend on animals in a way? Or for plant they can exist on their own, no need for animals. So yeah, Emanuela Diamond, your hand just came up. Yes, Emanuela, your hand is
Yeah, animals provide plants with carbon dioxide, and plants provide animals with oxygen. Human and plants also get shade from plants, and woods are obtained from plants, which are used for providing shelters for humans and animals.
Okay, thank you very much. You've all done well. Yeah, and also there's one thing that I haven't heard. So it seems that we all depend on each other, and plant most of them that need pollination by insect, they'll demand animal, that's the bee, the butterflies, and other insects that will be feeding on their nectar to help them pollinate. So they will need animals, or let me say particularly insect. Some also will need man for their disperser, or birds for their disperser. So in a nutshell, we all need each other, just that comparatively animals might need plants more than plants will need, but in a cycle of their life, they also need an insect or a man to help their propagation, also to help their continuity, that is their pollination, dispersal, and the rest. So we all depend on each other. As someone rightly said, we will take their oxygen, they will take their carbon dioxide. But in some part of the day, that is in the night, they can also produce their own carbon dioxide from respiration, which they can use for their photosynthesis cycle. But they need more, so normally they will pick more from the environment to have a better photosynthetic pathway. So it's not just about animals and plants. Animals also depend on each other, because some will feed on some other animals, some will also need others as their host, as we talk about symbiosis. So what keeps the ecosystem, so let me say the environment running, is the interdependency. We all need each other. So in a social setting, that's why we say no man is an island of its own. So at least you need other people to be able to survive, or also do whatever thing that you are doing. So no one is an island. We need each other, especially now that we are in a social setting, and with other people. So living things as God created, we need one another to maintain a very, very effective and a self-running ecosystem. So it means that living things rely on each other, either organism in the same species or with other species of organisms. It depends on the level that they are relating, and this helps them in their survival and also their well-being within the ecosystem. This interdependency is a fundamental aspect of ecological, so that is a fundamental base for ecological relationship, and this plays a very effective role in maintaining the balance in the ecosystem, and also in shaping the structure and function of the ecosystem. So it's a central feature of all ecosystem. There should be a system that put everything in check. If someone is bringing out waste, someone should be there to take that waste. If someone needs energy, there should be an organism or a source to provide the energy deficiency in the ecosystem. So it's a central feature of ecosystems, and it shapes the life patterns and population of organisms, the population dynamics. That's about the changes. Is the population growing, decreasing? Is it at the plateau? Is it at the lagging phase? Is it at the exponential phase, or is it at the declining stage? So the change that occur in the population all depends on the interrelationship between these organisms. So we said when the last tree dies, the last man dies. Why? Because we will not get enough oxygen for the last man. So it means that the population will change or become better when we are growing more trees. It means at least these these waste that are accumulating will be reduced. Also, global warming and the rest will be reduced. There will be more plant life, there will be more animal life as well, and it continues in that way. So we are now focusing our attention on forest. So we talk about forest ecosystem. We know this is dominated by trees and larger plants. Then with a canopy formation whereby we have the larger plant, then different gradation of plant. We have wild animals over there and a whole lot of variety. That means a biodiverse environment, having different type of plant life and animal life in such a forest zone. So we are looking at some interrelationship within organisms in the ecosystem. So I'll just mention some few from the screen here, and I'll invite you to also bring some other contributions. If there be any question too, you can bring it on board as I proceed. So the forest exhibit a high degree of interdependency, and the reason is it is extraordinary biodiverse, because a whole lot of organisms are there. When we enter grassland, there are some animals we will not find there. Normally the wild animals, I doubt if there could be elephant in a grassland. I'm sure maybe the animal would have been domesticated or been kept in a wildlife preventive or conservation zone. So normally they'll be found in a deep forest. Lion and tigers, some could be found in those areas, but predominantly they'll be more in the desert where they can find their game or other animals to feed on. So we have a whole lot of trees, animal life, plant life over there in the forest zone. So there'll be a great level of interdependency. The point when we are many in a social setting, we depend on each other so much. That is why in the extended family, anyone can even call you, and whatever you own could be anyone's own. But in the nuclear family, just two or three of you, five of you in the nuclear family, that depend on each other. But in the extended family, like when you go to some villages, everyone is everyone's person or family relative. They can all extend hand when they be need of. So there's a high degree of interdependency in the forest zone because it is very very biodiverse. So plants and animals and decomposing. So I told you plants will be the producers, animals will be the consumers at different levels. Then there will be decomposers, which are not normally put in the food chain or food web, but they are needed at the end of every food chain or food web to recycle the food. If they are not there, there will be no recycling. Now we know the importance of recycling so that waste does not accumulate to lead to death or toxic build-up in organisms which can lead to death, as I said earlier on, or there will be effective use and reuse of material. So that is the work of the decomposers. They are needed over there. So let's talk about the primary productivity and shelter. That is the first type of relationship we will talk about in a forest zone. Most of them will run through, especially when they are in the same habitat, whether the terrestrial or the aquatic. So here, primary productivity and shelter. When we talk about primary productivity, it's talking about the primary producers. Let me say the producers because we don't have primary producers. So it's like the producers, they are bringing the food into the ecosystem. So it's the net amount of energy or food that the plants, or let me say the producers, will provide into the ecosystem, and that is from the sunlight. So the sunlight will shine, organisms that can make their own food via photosynthesis will trap the sunlight with their chlorophyll. They will make food from inorganic substances, and the food that is brought into the ecosystem becomes the primary productivity. So what which organism will do that? It will be the trees and the plants. They will do the primary productivity or the net productivity of food. Then the consumers will start from primary, then they will continue on eating until the end of the food chain or food web. So in forest ecosystems, oh sorry, so in the forest ecosystems, trees play a foundational role. Why are we saying trees here? Because it's a forest, so trees will be the dominant, let me say, green life over there because they form the canopy, and beneath them will be lesser plants and shrubs, and so they provide, but not just the trees, even the shrubs and other herbs over there do play the role. But here, producers that is will make the food available for us in the ecosystem. Then through level of eating and being eaten, the primary consumer, secondary will now take off the food over there. So what happens is that the trees will play a foundational role. That is, they will bring food into the ecosystem for other organisms to get a food source to feed on. So they provide habitat. And remember, trees, they are very large. They can provide medicine for animals or animal life over there. They also serve as habitat because a lot of plants can live in that tree, and some other bacteria and organisms can also live in the roots of that tree. So they serve as habitat for a whole lot of animal and plant animal life over there. They also provide oxygen, as someone said earlier on, and they also serve as source of food for herbivores and some other omnivores. And also many bird and insect species rely on specific trees for nesting site for food source. So the plant life over there will serve as energy production or producing agent. They will bring energy or food into the ecosystem. They will serve as food, they will serve as shelter, and they provide oxygen for other animals over there. And also the provision of carbon dioxide and pollination, which will be done by animals. So as we said, plants will have what they will do, and animals also have their role to play. So animals also provide them with carbon dioxide, enough of it, and also help in the pollination and the dispersal of the seed and their fruit. So that is the role they also play to help the plant life in such a forest ecosystem. So the animals in turn provide the with carbon dioxide for photosynthesis. Many flowering plant species in forests will rely on specific pollinators so that they can have successful reproduction to also increase their numbers and spread across in the forest ecosystem. Also dispersal, what I've talked about. So fruit eating birds, which we call them frugivorous, they also feed on the seed or the fruit of these plants, and as a result of they feeding on it, they will go and defecate, and as they defecate or ingest it, some of these will not be digested because of the hard tester and covering that covers them so that it doesn't become digested. So once they defecate over there, it can spread out and grow to become a new plant over there. So that is what happens in the disperser. Some too will take as they eat it, they spread. Like for human beings, you pick a mango, you eat it, you throw it somewhere else, and as it land over there, it can grows back. So that is one thing. Another thing is competition for light. So the trees themselves also compete with each other, and that is for light. And there are another plant that will grow on another plant. So a smaller plant growing on a larger plant, we call them epiphyte. So it's like commensalism, another form of talking about commensalism, whereby a smaller plant will grow on the another plant which is larger. And normally when they do that, it is in way of receiving sunlight. So it's like commensalism, but a commensalism occurring in plant life, and we call that epiphytism. So it's also another type of symbiotic relationship. I didn't talk about the other time because I was not treating as a topic. But there's another type that we call epiphytes, whereby a smaller plant will live on the body of a larger plant in support for light so that it will get light. It will not feed on that plant. Remember, we also have plant parasite. That's a mistletoe, doda, and the rest. They are plant parasite. The one they've called akate and those animals. They and crampine, sorry, that is also a plant. So those who are in the western, they know such plant that will cause harm to the cocoa plant or some other plant species. But those are parasites. But the epiphyte example is the fern, which we will learn, God will learn later part of this year when we enter year two. Those are organisms and they're normally found on palm nuts. So they are on the palm tree, not just to harm the palm tree. They are not there to harm it, but rather on the debris of the fibers and soil that will fall between the branches that we call the axils. Then it will grow over there, not piercing into the plant. It doesn't affect any way. That is called epiphytism. So plant also compete. So for instance, if you have seen a plant that is planted in a shade, sometimes the plant will grow upwards and later turn just to escape. So if you have seen a plant being planted closer to a roofing sheet or closer to your house, maybe the roofing sheet covers it. When you grow to a point, you see that it will turn, or a smaller tree planted under a bigger tree. What happens is that when you grow to a point, you see that it will turn itself just to receive light. So trees that are planted in shade normally they don't grow straight; they try to curve themselves. That is a type of tropism or movement in plant for light. So we call it phototropism. Later we will learn when we are looking at plant physiology. So the animals will be competing for light. Why for light? Because light is a source of energy that they can use to get their photosynthesis. So light is like food to those animals because when they have light, they can prepare food. I haven't getting the point first. You too, when you get food, you can get energy, then you will live. So for them to they compete for light as we are also competing for food because that's the source of their energy production. So we see that the larger trees will dominate. They will form the canopy, like the larger. So when we are outside the forest, you see those larger canopy. But when you go there, you see that it's not only that bigger tree that you saw that are trees in the forest. There are a lot of zones or different levels of trees. So you get to the trash, sorry, to get to the shrub and the smaller herbs or grasses as the carpet of the forest zone. So they compete for light. So those that get more light, they'll continue growing larger. Then those that can creep also creep around the bigger trees just to also get fresh air and also get enough sunlight when the sun shines. So plant will compete. So we see here those that will form the canopy, they will shade the smaller one, and the climbers, so those who can climb and creep, they also climb, and you see that there will be some leaves on top of the plant. That is those who are privileged to be able to climb or creep, they will also be surviving. And undergrowth species adapted, so those that are undergrowth, they also try to adapt to low light conditions, and they can thrive below that. So if you can't accommodate or adapt to low light conditions, and you can't grow to become a canopy, then you become extinct. So here's like survival of the fittest. So this competition drives vertical stratification. When we say stratification, it means layers. So we have very light tree, the canopy, then we come to a second level of the plant over there, till we come to the lower grassland or shrubs. That will be that. That's called the vertical strat. So it's like a vertical layering, vertical level of trees based on their height and their light adaptation levels. Then we can come to decomposers. So you see here we have a lot of diverse animal and plant life. So decomposers too will be here a lot. That is why forest land are very fertile, because we have a lot of decomposers there that are trying to convert the dead organic matter into resourceful nutrients for plant production. So decomposers such as fungi and bacteria in the forest will play a very vital role, and the role is that they will break down this organic matter just to release energy into the ecosystem once again, and that is how we rely on each other. Remember, these decomposers, they also need animal and plant life which are dead or decomposing, so that which are dead, let me say it that way, so that as they feed on them, even if you are not dead and they feed on you, they can try to break you down to release energy into the ecosystem, whilst they also absorb the nutrients from you. So we all depend on each other, and the cycle continues on and on. So everyone is important. So when we come to our social life, some will be the doctors, some will be teachers, some will be lawyers, some will be drivers, some will be the maid, the conductors, some will be, so a whole lot of people are around. We all play a role. If all of us become doctors, who will teach you? If all of us become teachers, who will be trained to become the veterinary doctor or the medical doctor or any other person that we know? So we all depend on each other. If we are all in a white collar job, who will be fixing cars, who will be washing washing cars, who will be in the laundry, who will be wherever that is, who will be in the market selling for us, who will be even in the farming for us to get food to eat. So at least everyone plays a very vital and crucial role in the ecosystem. So that is how it happens over there. So the composers are like the zoom line, or let me say the sanitation officers, and they play a very crucial role, because if they don't do so, filth and waste will accumulate, which will cause serious death. Then we can talk about predation, that is animals competing. So plants will compete with their own species or different plant species for light, which will compete for a whole lot of resources. And not just for light, they also compete for resources even in the soil. But ours become predation, whereby we talk about it the other time. The predator will try to catch a prey and use the entire prey as food, or sometimes even part of it. But normally, most predators try to eat more or most of the part of the prey. So at least because it has killed it, hunted for it, and eating at least a little part of it, it is called predation. So remember, the prey is always vulnerable. They also, God, let me say, nature also provide them adaptation. But in as much as they try to adapt, the predators too have to eat. So they also catch you on loose guard. That's the predation. And when they are feeding on plants, it is actually called herbivory. So we should take that to note. Then symbiosis, that is a close, prolonged feeding relationship between organisms. I explained this in the previous lesson, so just check from the YouTube channel if you didn't join us today. That is a mode of nutrition. I posted it today in the afternoon. I was working on it throughout the day, so you can go and revise over there. That is a close, prolonged relationship between organisms of different species, whereby it will be either mutualistic, commensalistic, or parasitic, which I've just explained some in some few minutes before I entered here. So that is symbiosis. At least we will need some cordial relationship, which will either make both of us benefit mutualistic, one person benefits where the other does not benefit or doesn't lose anything, that is commensalistic, or when one will enjoy at the expense of the other, and that become parasitic, symbiotic relationship. So nitrogen fixing bacteria, these are some examples. They will live in the root nodules. These are called the mycorrhiza. They will live in the root nodules and they will fix nitrogen for the leguminous plant or the beans. And they will also get shelter in the root nodules of the plant. They also get food there. So it's like you are in my apartment. You are bringing me nitrogen. When I get the nitrogen, I can make more food. You are living there. You also enjoy a full flat over there and also enjoy food from me because at least you'll be eating over there. So that's the benefit we are all getting. You bring me an ingredient, I'll give you shelter, and you also get food from me from the ingredient you gave me. So that is how in the forest ecosystem organisms do interdepend on each other. That is not all, but it's a brief an idea of all that happened there. So I'll pause at this point in time. If you have a question or any other addition to add, once we understand it from the forest ecosystem, we can replicate these in other ecosystems. Some may change, especially when we transition from the aquatic to the terrestrial or terrestrial to the arboreal or aerial. So once we move from one set of habitat to another form, things might a little bit change, but at least the idea is the same. So you have a question, you can ask a contribution, you can bring it on board. We are still looking at the interdependence of organisms in their ecosystem. Well understood. So now you're going to the wetlands. So the wetlands are home to specialized plant species like the cattails and rays, which can tolerate water saturated soil. So example is the Keita Lagoon complex. So this place is not actually covered with all water, but it's like I will call here is a like a marshy area. Let me make it simple. It's like a marshy area, a place whereby it's like the water is there, but it doesn't cover the entire place. So it's like in between a river and aquatic. Aquatic habitat and terrestrial. So a mixture of water. So the place look always muddy with water over there, but it's not enough to become a river or a pond. That's such a wetland, like a muddy area over there. So these are home for specialized plant species. So it's a mixture of plant and water over there. And not all plants can do well in such an area. So those that stay there are well adapted to such an environment. So they are home to specialized plant species like the cattails and the reed, which normally grow in such a wetland. Which and the reason is they can tolerate water saturated soil. So with a soil is like is like a mat. Let me say it that way. Putting enough water in a soil to make it more muddy and overflowing. That is the kind of place we are referring to as a wetland. So, example is the Songo Valley, Ketea Lagoon Complex, the Sakumono, Densu Delta, and Munipomazi. These are some of examples in our country here, and they also interrelate. Organisms do live there. So, example is nutrition and shelter. These plants that we talk about, as the cattails and the rays, they provide food. Always, you see, the point is the same. Plants will be the producers everywhere. Photosynthetic organism will always be the producer. When you get to other aquatic, you might not hear only plants. You hear the algae and the rice because they are having the chlorophyll in such an ecosystem. So they provide food habitat for various animal species such as the insect, the bird, the mammals, and if probably there are human beings there, they also enjoy from them. But normally there will not be as much as other animals in such an environment because humans are not restricted to such areas. Many bird species are dependent on wetland because normally they do go there, feed on the insect, also get some water over there, and they also breed over there, and they are stopped over during migration. Remember, there are some migratory birds, and so recently it came over on television whereby a bird supposed to be from Belgium. I forgot, I'm sure it's from Belgium. Like they found a place in Ghana here because of the inscription on it. So normally these birds do fly some from South Africa to Asia and some other UK European countries. So they do migrate. So there are these white birds. Sometimes you don't see them around. Later in the year you'll be seeing them. All these are migratory birds that do move from one continent to the other. So normally when they get to these places, they do stop over to feed on, get enough water, get some other organism to feed on over there. So that is one example of the wetlands and how organisms interrelate over there. So some fish and amphibians also rely on temporary pools treated in wetlands. So remember, amphibians also need water in the cycle of their life. That's why they are called amphibians. So they can live on land, also live in water. So they will need to spawn their eggs, which will go into the tadpoles in water. And no fish also need water for them to survive because the wetland sometimes some place become covered with enough water for them to also survive for their spawning and their growth in such an area. So that's the nutrition and shelter the plant will provide. Then shelter will be given by the plant also over there. Now decomposition. Every ecosystem there should be decomposers because waste will build up so much. So decomposers too are there which will break down the dead plant and also release energy into the soil. Plants will also get use of it and it continues over and over. Under the decomposition side, in every ecosystem I was talking about, there should be decomposers that will convert the build-up waste into something harmless or useful to the ecosystem. So the waste will be eliminated and nutrients will be provided in the ecosystem for plants and animals to use or rely on for their growth and also for their basic cellular activities. So that is the decomposers over there. So they will break down dead plant material and recycle nutrients through the ecosystem. And this nutrient will support the growth of algae. And remember, algae too are producers and other primary producers which will form the base of a food web. So it's not just a plant, but any photosynthetic organism that can have the plastic chlorophyll. They can also produce their own food, and other smaller organisms or larger ones can feed on them in a cycle or in a sequential order to get a very good interdependent feeding cycle or food web. So that is what the composers will do over there. When we go to the grassland, it's just the same thing. Grassland, so we know we have a lot of grasses there and they'll be grazing. So if they are grazing, then there should be ruminant organisms that feed on the grass. So in the grassland, grazing, we can't ignore grazing. We can talk about grazing because herbivores will be there, a lot of them, and they will be feeding on this grass. And as they feed on this grass, other organisms can also feed on them. So we can have grazing as a major interdependence or a major biotic component or biotic factor. Then predation, since we have a lot of these herbivores, then there will be a lot of predators to the wolves, the lions, and the rest that can feed on the zebra and the other herbivores. So we can have a lot of predators in this grassland. And the reason is they also regulate the herbivore population. So that is one factor that they also play. And the reason is when we have a lot of herbivore, they can in turn cause extinction or overgrazing, which will make the land bare. So there will be more also predators, which also check population of the predators. So in other way, there will be a balance because if you have a whole lot of herbivores always multiplying, they are not being checked, they will end up overgrazing and the grassland will now become a desert. So once we have a lot of herbivores there, then a lot of it means that if you have very few lions or predators there, they can also get enough food. So the more they get enough food, it means that they could be feeding more and more on the herbivores. Then they will be checking or reducing their population. If they also become too many to the point that the herbivores are very low, what happens? They will now be starving. As they keep on starving, population will decline. They cannot reproduce them more. Then as they're declining, population of herbivores also increase. So that's called population dynamics. If you have enough food, you eat very well, you grow very healthier. They become too more, the food becomes scanty for us, then something happens. The cycle goes on and off. So that is the predation. Then symbiosis, I've explained it several times. There's also a symbiosis because we have the grassland there. Probably there could be some, how we call it, some leguminous plants over there, and they can form this mycorrhiza symbiotic association, whereby they will rely on each other, and some organisms too are in the grassland which can also try to depend on each other for food and sometimes for accommodation purposes. So these are the symbiotic association in the grassland. When we go to the Arctic tundra, similar thing also happen. We can have symbiosis, we can have predation. Example is the Arctic fox, which is a predator in the ecosystem. It relies on small mammals like the lemons for sustenance. So the predator will be there just to feed on the herbivores or some other organisms or omnivores over there. And migration. Why migration at this point? Because the Arctic center, they have extreme conditions, very very cold because they are around the polar regions. So the organism do migrate when the zone becomes so cold and that they can't adapt to such extreme condition, they move. So the tundra also has numerous migratory bird species that rely on the region's abundant insect population for food during their breeding season. So migratory birds also move there. The reason is during set time we have a lot of food for them. So once they have enough food, they can keep on. They become very very fertile and productive. Then they will keep on having enough offspring or progeny. So that is the reason we have migration over here. So the migratory birds will move to those areas during their breeding seasons because of the abundance of food for they themselves and also their young ones when they bring them. Then we can talk of the coral reefs, which is almost the same thing, symbiosis. So corals and algae, and this is their symbiotic relationship. That's a zooxanthellae, and they have a symbiotic relationship. So remember, we have what we call a light chain, which is between bacteria and fungi, and we have zooxanthellae, which is corals and algae. That is their symbiotic relationship, and this is how things go on. The corals will provide the algae with a protected environment, and remember, the fungi will play the role like the corals, and the algae will play the role just as the bacteria that we learned about in the lichens. So the coral provide the algae with a protected environment, and the algae provide energy-rich foods in return because the algae is a photosynthetic organism. So you see, we all get benefit. I protect you, you also give me food. So it's a kind of mutualistic symbiotic association. So that is the main thing that we can talk about association. Then we can go to them. So we see that in each of the ecosystem we can hear of symbiosis because interdependency is strictly needed for organisms to survive. Then we can move to the river aquatic ecosystem whereby we need provision of food and oxygen. So food could be by the algae, and remember there are some plants also in the water. We have aquatic plants, and these also will provide them food. And the algae too are there, very smaller organisms that will provide food. So other organisms will feed on them. Then the cycle continues till it gets to the larger or the apex predator in the aquatic habitat. And in turn, herbivorous species like certain fish and invertebrates will graze on these primary producers. Now, predation will come in. Other organisms can now go and feed on the primary consumers, and decomposers too are there trying to clean up any mess we did over there. Then symbiosis, where the organisms will rely on each other for their survival. So that is example of them. Then we have anthropogenic activities. That's when human beings also play a role over here. That is like our activities such as pollution can affect them, which can kill a lot of these organisms there. And we can also destroy their habitat based on farming around rivers and such areas can also dry up the river and also pollute them through runoff of fertilizer and other chemicals. So human also activities affect them over there. Now we are done with a brief looking at how they depend. So now you see the organisms depend on each other. One, for their survival. Why their survival? They will need food, they will need oxygen, they will need carbon dioxide if they are plant. They will also need protection. That's why they undergo symbiotic relationship. So and after that decomposers must come in. So we must hear food production, you hear decomposing, cleaning off, and we can hear other symbiotic relationship. And some also migrate. So these are the basic ways in which organisms depend on each other for survival. So normally someone will never call a friend unless he or she needs a favor or needs some sort of help. So that is not the best though, but at least we do need each other for survival. So we always call for something because we need there's a need to address something. That is how organisms rely on each other. Some are so natural that it happens around the clock, it happens unknowingly over there. So these are the things that we do happen or occur in an ecosystem. If there's some question you can ask at this point in time, you can raise up your hand if there's something that you'd like to understand. We'll just look at the outcome of it, then we'll end today's lesson. The next time we'll talk about this, that is the estimation of population, where we'll talk about the various ecological tools and how they are used. Okay, so now we've realized that organisms depend on each other. Now, what is the outcome after the interdependency? So, as I told you earlier on, it makes the ecosystem balance. We have a stable ecosystem. So the outcome is that living organism in the environment is a complex web of life that sustains the Earth's ecosystem. So it one brings a system called ecosystem, a stable unit that can support itself because the organisms are dependent on each other. And this provides habitat for diverse species and essential service for both nature and humanity. So each organism will get its own share of the environment goodies. So anything good over there, it runs in a cycle, then the decomposers will end it all when it gets to their side of the cycle. So it can lead to ecological balance. Also, it can cause biodiversity, whereby we can have different organisms inside the same community enjoying all the good things that is being presented to them. So we can talk about reaching a stability. So one, the key outcome is this: we can have ecological balance. So everything that nature or God provided is trying to balance things out. If you have a lot of predators, prey population will reduce, and if it reduces, in effect it will affect the predator population because there will be lesser food, they will starve, they cannot reproduce. So as the numbers is reducing gradually, preys are also getting enough time to balance their point. When they reach another point, now they have more food, it zooms. So now it's like a seesaw trying to balance. When there's an imbalance, either one will go extinct, and if your food finishes, what happens to you? You will starve. If there's no food, apparently you will die some years, not even years, some days to come, because there's no other food for you to live on. That's why I'm sorry to say, once people are about to die, some will stop eating a week or two. They're not taking any food, just drips and all. So later on, when they cut off the food source, the person will die. That's what happens. So it tries to balance itself. If you have a lot of waste, no decomposers, a lot of organisms will die out of pollution. So interdependency helps maintain ecological balance, and this regulates population sizes and prevent any one species from dominating an ecosystem. So if there are a lot of locusts or grasshoppers, that will call for more organs that feed on them. So lizard will be there. So lizard population will increase. It will increase to the point that there will be more lizard because they have a lot of food. As they're becoming more, they feed on a whole lot of insect over there, the locust or the grasshopper. Then something will happen. Population of the insect will reduce. Now we have a lot of lizard there, they will be starving, not enough food for them, so they cannot produce as much as they're producing. Some will die, some also move from the same ecosystem, they will go to different places, people migrate. Then the point is, it will give chance for most of the grasshoppers to grow again. Then they also go become dominant again, then it continues that way. So it brings about a balance over there. So, for example, predators keep prey population in check, and this prevent them from overgrazing or over reproducing. And when they do that, it affects the ecosystem. It becomes one way, or it also exceeds its carrying capacity. So something must check that. Second one is biodiversity. That is when we depend on each other, it also brings the biodiversity over here. So interdependency promote biodiversity. Why? Because different species rely on each other for their survival. So I rely on you, you also rely on me. So we try to support each other and we all stay. If only one person, if only plant could have stayed on their own, then all of us would have died. But at least we all need each other. Plants need animals, animal need plants. So we all stay together. So if one person could have done everything on earth, I'm sure that most of us wouldn't have been here. So at least you need each other. You need a plumber, you need the auto electrician, you need a mechanic, you need the cleaner over there, you need a doctor. So at least you need everyone around you just to maintain your systems. So that is why it brings biodiverse. If only you could have sold your address, you could have done everything on your own, then there's no need calling for other services. So that is why we have different services. Something that you can't do, another organism will be there to provide for you. So that means that they are also needed and they will be around just to keep nature in balance. That's why it causes biodiversity. Then nutrient cycling. If you have money, you don't pay for a service, you don't pay for a product, then the money will still be there. So the nutrient too has to recycle. Organisms have to feed on them at different trophic level. As the energy cycle, nutrient cycle around, the composers will be the last sort to recover them so that it could continue again. So nutrients move in the ecosystem, and that is in the food web, and also the carbon cycle, nitrogen cycle, and other cycle. So the composers will break down the organic matter and they'll release nutrients into the ecosystem back again. So this causes energy to flow and in balance, so each one will get a share. So for instance, if I have 10,000 Ghana cedis, it remains 10,000 Ghana cedis. But if I start spending, I will give 1,000 out to the plumber, another 1,000 to another person, 1,000 for my health, maybe 2,000 for rent and other things. You see that the money is now spreading. Now the person that I paid may also need my service as a teacher, or maybe buy a product from me. Now the person will bring that 1,000 back. Now I had 1,000, so that was it. After I finished spending, another 1,000 has come. So now it's now 1,001. I also pay for another set. So if you remember, the 1,000 Ghana cedis in cycling will produce more than 10,000 cedis, maybe 50,000 cedis, based on the transaction we will do over that. So if I have 10,000, I transfer 10,000 to you. You transferred it back. The money remains 10,000, but the transaction we have done is not 10,000, rather it's 20,000, because I gave you 10,000, you also transferred 10,000. So on our balance sheet, I have 10,000 in, 10,000 out, that become 20,000, but in the account wallet, it will still be 10,000. So that's the power of cycling. As the movement nutrient also move, it creates a lot of organism over there. Now that because as it move, organisms also get their nutrient cycle, then they stay over there. So the money that the government will print will stay there. It may be maybe a 1 billion Ghana cedi, but at the end of the month, as the money circulates, it will be worth more than a 10 billion the government printed, because you'll be using the same money over and over again over there. So that is the nutrient cycling ecosystem, which helps support the organisms over there for their survival and sustenance to increase the biodiversity we just talked about. Now we call something ecosystem services. So some will say home services. When they come, any service that you need, maybe that you couldn't go to their office, they can attend to you. Maybe dishwashing, laundry, anything over there, repairs they can also do. So ecosystem services, that talks about interdependent support or provision for the ecosystem. Example is the pollination that will keep the plant also being uh, fertilizing each other, whereby they can do cross fertilization or even self fertilization through these processes. So that is water purification and soil formation, and these services will result in a complex interaction between the organism, and they are essential for human our well-being. So these are some of the influences that can occur in the ecosystem due to the interrelationship and the interdependency, whereby the insect will depend on the plant for its nectar for food and the pollen grain for food, whereby as it feeds on these two things, it also helps transmit them, let me say transport them for pollination to occur. And also adaptation and evolution. organisms tend to adapt and tend to evolve or grow during these activities. As they depend on each other, they begin to evolve or adapt very, very well to a particular environment, and this helps in their behavior and their adaptation because I depend on you. So I will learn how much to relate with you, to depend on you for life. So organisms like the bees, they have adapted. They have what we call a pollen bag. They have these nectar collecting bags that will help them. So they've been adapted to feed on the nectar, and also as they are there, their feet are pro-leg are now there to pick the pollen grain so that they can pour on the stigma of the plant. So that's the adaptation. Now they rely on the nectar, and their bodies adapted so that as they are moving, they can be picking up this pollen grain for the transport, or else they'll be feeding on the pollen grain for nothing, and it will not help the plant to also pollinate. So it adapts the organism. How best? So now we see these animals like the predators, they adapt. They try to find means so that they can be catching the prey, and the prey also try to adapt so that to avoid the predator. So we all try to adapt and evolve. So we say that as the hunter tries to shoot the bird without missing, the bird also try to also fly or not perching for long so that the farmer can't or the hunter can't shoot it. So they all try to adapt and evolve. So the more you become smarter, I also bring a new term. So that is how organisms adapt and evolve as they interact with each other, either for the benefit of both or to the demise or to the negative effect of the other. Now, resilience. Ecosystem with higher interdependency tend to be more resilient. So, because a lot of organisms are relying on each other, so it becomes so resilient and resilient to disturbances because it is always having a lot of disturbances or interdependency. So it becomes so, let me say, so stable to the point that little disturbances cannot shake the entire ecosystem. It has been built upon the disturbance and the interrelationship. So it can cause resilience, and this happens when there's a higher level of interdependency because we all depend on each other. So it's like you being in a nuclear family, something small could boil, but in a extended family, someone troubles you are trouble. So like you become fed up, and nothing doesn't move you anyway. It's like someone working in the hospital, they face a lot of blood and emergencies. So when they see that even your head is off, not that they are not human or they are humane, yes, they have passing for it, but they've seen a lot of times. So if you are bleeding, it's nothing serious or to panic about. But when you see someone just cut a fingernail and have a slash in the skin, you will panic because you don't see blood most often. So in such ecosystem, there are a lot of interdependence, so they are stressed out already. So nothing doesn't move them that much. So it doesn't cause change. So that's the resilience that it built over there. So just coming the ecosystem doesn't change it because it has been built upon a lot of interdependence, whereby prey feed on the predator feed on prey, a lot of cycling of nutrient and rest. So they become a little bit stable and resilient to disturbances. So, as I said, it leads to a stability over time. So they could be stable over time, and that is when it has reached its carrying capacity or its brain. Now, human impact. Human also play a very crucial role in every ecosystem because the point is our impact could be very, very, very detrimental because the way we do organism will go little, but humans, if we are affecting the ecosystem, we go in multiple and manifolds, whereby like pollution, we can create a lot of pollution within a day. That organism will lose about years to cause that same pollution. We can cause a lot of damage that organism can take centuries to do. The other organisms say that way. So human activity like industrialization and some of these things, production, also a lot of waste accumulation. So we can produce tons of waste more than other organisms can produce naturally on their own, and this affects the ecosystem. So because of activities, we have now been poaching organisms. We have now made some organisms extinct. We have now tried to move some organisms from their natural habitat because of urbanization and industrialization. So human activities are very crucial are very crucial to affect the ecosystem, such as habitat destruction, we pollute the environment, climate change, and all these affect them. But if we are to channel in good conservation activities, we can also impact like wildlife conservation. We try to make protective zones for these animals and try to also plant trees. It will help the ecosystem. But due to industrialization, urbanization, and we trying to become so modernized, we end up destroying and having a negative impact on the ecosystem, which shouldn't be so. So some people say that even if God doesn't come or nature, human ourselves will even destroy, because the rate at which we are polluting the environment, Ghana here we are galamseying and the rest, we end up build up toxic in the ecosystem, which affect not only us but in a higher degree our predecessors, because there will be a lot of waste that decomposers can't take off. So that is the kind of mess we are creating for ourselves and our future generation. So human impact plays a very, so among all the biotic factors, human influence is a very crucial point, because human, our activity and influence could be so magnified that it affects the ecosystem more than it can recover on its own. So these are the outcomes, the effects, which could be negative or positive, of the interrelationship between humans, sorry, between organisms in the ecosystem, the plant and animals, and whole lot of organisms over there. If there are some questions, you can bring it on board, we can address them. You can raise up your hand. I'll end the lesson here so that next time, which is tomorrow, if only there will be enough time for us, we will look at the various ecological tools and how they are used. So we are coming to look at population estimation, and this is what we will talk about when we meet God willing tomorrow. If you have any question on the interrelation between organisms and the outcome of the interdependency between organisms in the ecosystem, you can bring it on board. Questioning time. If you have a question, you can ask. If a hand is up, the person can talk. I'll wait for the next minute or so, then we will call it a day. So same time tomorrow, God willing, we'll be looking at the various ecological tools and how they are used to estimate population. So this tells us that organisms actually rely on each other in the ecosystem, and it's for their own benefit first, and also the benefit of sustenance in the ecosystem. Alright, there are no questions now, so I think we all do understand. No negative reaction. So thank you for joining us for tonight, and I'm sure it was a great time having together. So God willing, tomorrow we will look at the other aspect that I talk about. Let's meet same time tomorrow. Have a good night. Bye to you all.